Hello and welcome. Today we will be discussing an exciting development development in the world of mobile-driven authorizations. We will explore how the latest enhancements of the Primus HSM REST API is changing and what processes have been introduced. Provider greater efficiency and security. So let's dive in. Before we jump into the details, I'm Sebastian Fernandez, and I'm working at Securosys. I've been developing on these API enhancements of the REST API, and I'm excited to share these improvements with you. We're going to talk about, or what we are going to talk about today is the REST API. Then we will have some real-world use cases, MPC with REST API. We will explore smart key attributes, which are actually policy-defined on keys enforced in the HSM, protected by the same tamper-proof and enclave to execute these key operations. Next, I'm glad to introduce the Securosys Authorization App, the mobile application, and at the end we will have a quick demo. So let's start with what is actually a REST API. We have a client and the REST API, which is running in a Docker container. The client communicates over HTTP with the very well-known verbs post, get, put, and delete. The REST API is then, after receiving the client request, establishing a connection to an HSM or an HSM cluster, load balanced for sure, and is speaking the proprietary protocol, which is then returned back, and the REST API is returning the response in a very slight format such as JSON or XML. So many of you have been maybe using the REST API as for now, and these are the latest enhancements of the version 2.0, such as a new authentication mechanism has been introduced. Besides MTLS with OCSP or JWT token, we are now, or the REST API is now capable of using API keys. And with these API keys, role-based authentication has been introduced, such as key management, key usage, approver management, or monitoring endpoints. Besides that, the REST API has improved on has added functionality for the Securosys Authorization App, and to generate approver keys for the smart key attributes, which will be dig deeper a little bit later, generated by and with HSM entropy. Additionally, we have certificate management introduced, such as CSR generation, self-signed certificate generation, and certificate issuing. And of course, the NIST PQC algorithm supported the latest for sure. Lastly, file encryption such as ECIS has been introduced as well. So let's talk about some practical use cases, how and when you can actually use a REST API and what are your easygoing implementation and integrations, and what are the more custom-based implementations you can do using the REST API. The REST API is capable of having multiple functionalities such as sealing, key management, signing, encryption, root key management, and double key encryption for Microsoft. It offers direct integrations into all major blockchains, such as Ethereum and Bitcoin, a HashiCorp Vault Community Edition integration, and support for Docker encryption, signing, MariaDB, TD encryption, support for eJPCA, and the Securosys 365 double key encryption service used for the Microsoft Information Protection in order to encrypt your Office applications such as Word, Excel, PowerPoint, Outlook, emails. Besides that, using the keys on the HSM for cryptographic operations, the transaction security broker functionality comes into place in combination with this new mobile application. But first, before we introduce the mobile application, we have to understand why do we even need a mobile application in combination with the REST API. And the use case for the REST API in combination with MPC, multi-party computation, is when multiple stakeholders across the globe in different departments have to come together to sign certain challenges. These challenge just providing a signature, and if all of these signatures come together, the transaction can actually be signed off. Examples such as large financial transactions, most of the time more than 100K, or multi-signature wallets, such as experienced in the blockchain for hot and cold wallets. Another thing, and that's primarily the demonstration later on about, is about product launches and feature rollouts. Because in a product launch, we have multiple stakeholders, the engineering, the manager, release managers, the marketing and the legal team. They have to come together and have to sign and approve what they actually, or the feature being released. Other examples such as root certificates, which need enhanced security because they are very long-lived, and things like document signing of legal contracts. Smart key attributes are a very powerful tool in this environment. They enable fine-grained control over private key usage, whether for signing the contracts, decrypting sensitive data, handling long-term certificates. They are leveraging an N out of M quorum concept, meaning 2 out of 3 have to sign in order to get the transaction through, and only approved after a required number of stakeholders sign off. Sorry. So what are smart key attributes? They are, or it is, a policy attached on the key stored inside the HSM, enforced within the HSM. So we have a couple of rules, and there are rules such as use for cryptographic operations, modifying the policy, blocking or unblocking the key based on or if a security incident happened. Another thing are tokens, and tokens are associated, so either one token or another token, all the approvals have to be fulfilled. Nice features like time lock, timeouts, so working with time can be specified in a smart key attribute policy. And lastly, we have a so-called group, which is AND associated, and on the group itself there, the quorum is to be defined. For example, if a large transaction needs approval from multiple parties, you can set rules to require multiple signatures and even conditions like time delays for extra security. A quorum can be set such as 2 out of 3 approvers needing to sign off. Each approver consists out of a public and private key pair, which is onboarded on the policy. This makes the process and the smart key policy very flexible because you can specify customizable rules. Now, let's discuss what the TSB workflow engine actually, or which powers the backend logic for managing your approval or your transactions and routing the requests through different stages. We have on the left side the business application, and on the right side our REST API. The business application is requesting the REST API a financial transaction, so a signature basically generating, and the business application gets and receives a request ID. This request ID has to be stored for later within the business application. The REST API knows that it is a key with a smart key attribute, which means it needs certain type, or it needs some approvals. The business app, or the that's where a mobile application comes into place and provides these kind of approvals to met a quorum. The mobile application fetches certain challenges, the approval challenges, and is signing with this private key these challenges and returning it back to the REST API. The REST API is then checking whether the quorum has met N out of M, and if everything looks good and within a certain time, it is establishing a connection to the HSM. The HSM checks again if, or the HSM enforces the policy, and if everything has met, the result, the signature is returned back to the business application. With that and the knowledge of our approval app to met a quorum, we are very thrilled to introduce you to the Securosys Authorization App, the next generation in mobile secure authorizations. This app is, as said, empowered to businesses to support multi-party computation by providing a seamless, user-friendly and platform to approve transactions, digital signatures, certificate management directly on your mobile device. Biometric authentication set on your smartphone's default, such as face recognition or fingerprinting, can be enabled, and in order to unlock and log into the approval app. Here you can see an example on how the challenges are represented, and the approval app will automatically fetch in the background the challenges and notifies the user in the notification bars based on the severity of the notification with different icons. We have made sure, because these background processes can consume a lot of mobile phones or smartphone battery. We have made sure that the requests are as small as possible. Anyway, today's smartphone don't allow to idle CPU that long anyway, and so we had to stick to that. So if for example, a approval or an approval request has been typed, the metadata is being displayed, so what am I actually approving? And the nice thing about this is that the metadata being displayed can be completely customizable by providing the output or the input for the approval details as a JSON format, and it is represented in a nice looking way. So for example, this is the Ethereum blockchain transaction and requires approval. When hitting key management on the bottom of the overview slide, we have key management, which provides users with approvals, such as modifying the policy, unblocking and blocking the key. The last tab is a settings tab where you can put or disable biometric authentication and onboard your approver private keys. To wrap up, the Securosys Authorization App is currently in a beta stage. We are very open for any improvements and feedbacks from the community. It is available on the Google Play Store yet. Just type in Securosys and you will find it. iOS App Store is coming soon, and the keys, the approver keys, are generated within the HSM ephemerally, meaning the HSM doesn't know after creating the key, it doesn't store it, right? Just export it, wraps it, and then sends it to the approval app using a predefined workflow with one-time codes and authentication and transport encryption and so on. There is a feature to restore the approver private keys. So in case your smartphone got lost in Rio by a street, whatever, there is a possibility to onboard your private keys again, and your actual key is can still be used. Especially important if you are running on a blockchain with one single private key. The approval app can be used in combination with TSP on-premise, REST API on-premise, or TSP as a service running in the cloud, operated by Securosys in a platinum way with the enhancement of API keys. Quick thing about biometric authentication, it is built in. Maybe worth mentioning, the private key used within this app is stored within the smartphone's key store in an unextractable way and has a secure encryption. So even if your smartphone is rooted, you do not have access to the private key or other sensitive information stored in this app. All right, so coming to the end or to a demo, and I've been working on introducing a document or a artifact signing, so code signing solution within Securosys. So we have our software and firmware signed properly with HSM-backed keys, and we were using smart key attributes. And the basic workflow is basically you take sources from GitHub, from a public repository, and you build your image. Why is this repository public, one might ask? Because based on, there's somewhere, sorry, but this is an important one. The image and the source code is stored publicly because of transparency and collaboration purposes. Everyone needs to or shall be able to check your source code in order to spot any weaknesses. The next step is where you are taking your container image, your Docker image, whatsoever, and putting it into or hardening your image by removing certain dependencies, making analysis on this image, and then you are going, after the hardening, you are signing your image with a release key. Lastly, what you want to do, or your pipeline is going to is pulling the image from the repository, this time it's private, and deploying the container on a Kubernetes cluster. So here we do have a little repository with a pipeline defined in a GitLab CI. And we do have these three stages: fetch source and build, harden and sign, and deploy the application on a cluster. The harden and sign, so we want to quickly check what is actually the signing look like. We are using notation, a plugin, and we are using the sign command specified by a Docker image name, so what image we want to sign, and a HSM key. So going to the build server, we check quickly what plugins are available. We have installed the notation plugin and the plugin of Securosys HSM provider for notation. Listing the keys is actually just a reference, TSP demo signing key, and this signing key has a smart key attribute policy defined. The policy is a very simple policy, such as a rule use, I'm using it for crypto transactions, with a single token or associated, a group, and a quorum that only one approver has to approve the signature, the signing request, and the approver is here specified as such, the public key at the end. Going back or running this pipeline, and fetch source and build, we already have front, we don't need to rebuild it, but we want this to sign this time our image, so meaning it is release ready, depending on different departments in my company, marketing, legal, release manager, etc., has to approve this signature or this container based on a smart key attributes policy. And that's why that's what we are currently waiting of. We are waiting for the approvers to sign the container. Otherwise, I mean, the pipeline is currently at stuck. It will be approved if the quorum has met. The signature will be attached, or the hash of the container will be signed and the signature attached to the container, which is then stored in a GHCR repository in order to verify it later when deploying the application. So, but we are currently now waiting for an approval, and then approval looks the following. I'm opening the app, unlocking the authorization, or just doing the login. If there are currently no tasks, the application will check and retrieve challenges. And it found a challenge, some pixel bitrate problems, whatever. And we do see here that it is a project for production Nginx web server. We can even have a dedicated view, and we are going to sign this challenge, meaning we are okay with this hardened Nginx web server that we want to use in production. After that, we are going back into our pipeline, and we now see that it will continue because the REST API, Transaction Security Broker, has received all the approvals, signed approvals, will establish the connection to the HSM, sign the challenge, the hash of the container, and then executing the pipeline. And with that, we are now ready to deploy the application on whatever, Kubernetes, on my VM or whatever. And before we deploy it, actually, we are running a verification, and the signature checks out on whatever platform or on the end machine, VM, Kubernetes, whatever, it is usable. With that, job succeeded. I think my job is done as well. And thank you very much.